Hello everyone. Today I'm going to discuss on ML error matrix. What is this? So when you going to create a machine learning model and you create a model and now you have to measure the performance of the model. So this error matrix tell you how good or bad your machine learning model is. Just this is a mathematical method to measure the performance. So error matrix exists to definitively answer how much of a mistake is the model making. Just like exam marks tell you which student performed well and which performed badly. So error metrics tell you quality of ML model. Objective, they provide a unified mathematical score combining all individual prediction errors into one comparable metric. Okay. So why are they needed? Again explaining. So measure the quality. As I said, how good or bad your model is. So and now detect for learning. So metrics act as a early warning system. They help developers quickly detect critical issues like overfitting or underfitting. So based on the metrics, you can modify your model. So optimize training. Yeah, also um, so based on the metrics, you can just to reduce the prediction mistake. You can set the uh, I mean set the your or adjust your uh, different parameters. Okay, to reduce the error. So optimizing your training, uh, you can decide based on your uh, matrix, error matrix. Okay, so real life example: house price detection. Suppose the actual price of a house is 50 lakh, but our machine learning model predict its like to be 45 lakh. So mathematical error is the difference between reality and the prediction. Like so, here our model made 5 lakh mistakes. The error metric aggregates millions of these individual mistakes to give a holistic performance score. So during training, actually, we train the model in thousands of data, even millions of data. So actually, these metrics to find out the mistake from individual data and give a holistic performance score. Understand? Error matching is crucial for every use case, but here it's very important for like high stakes sector like banking and finance. Okay, where for any minor error, uh, you have to pay huge, right? Like if your model is wrong, suppose you predicting using your model, you approving the loan, whether the customer eligible for loan, based on the that model output, you just approve the loan. Okay, if your model performance is bad, you wrongly um, um, approve the customer's loan. It's very dangerous, right? Same case for uh, poor stock prediction. So minimizing error saves the millions. Same for healthcare. Very important thing. So predicting categories accurately is life saving, right? So minimizing error in this case very important to prevent wrong diagnosis or missing critical disease like cancer. Okay. Also, tech and automation sector like self-driving car. So here the error margin should be zero. Otherwise, accident will happen. Same for e-commerce. If your recommendation is wrong, this may affect the driving sales and user engagement. So error rate is very crucial. So now the problem versus matrix. Here I am going to discuss when to use what type of matrix. Okay. So as different problems require fundamentally different evaluation method. It's quite logical thing, right? For example, for predicting numbers, when forecasting house prices or weather temperature, you need regression metrics like MAE or RMSE to measure the numerical gap. For predicting categories, when detecting spam or versus not spam or cancer versus no cancer, you need classification metrics like precision, recall. So using a numerical metric on a categorical problem makes no mathematical sense. So that's why for different type of prediction, we need different type of error metrics. Again repeating, for predicting number, we need MAE or RMSE. For predicting categories, we need precision or recall. In the graph, you can see the regression is a straight line kind of thing, and classification here you can see separating to group. Okay, splitting into two group. Okay, this is a separator line. Now, again discussing the regression matrix or predicting numbers. Okay, so first metric is MAE. That means mean absolute error. Meaning, one purpose measures the average mistake. How it works? Takes absolute difference between actual and predicted values. When to use? When all errors are equally important. Now, MSE means squared error. Here punishes large mistakes. How it was square errors before averaging. When to use? When large mistakes are particularly dangerous. Next, RMSE, root mean square error. Purpose, error in original unit. How it works? Square root of MAC. When to use? Most common metric for overall regression quality. Now R square measures goodness of fit. How it works? Check how much variance model explains. When to use? To strictly evaluate regression quality. So these are the different type of metrics for regression metric. MAE, MSE, RMSE and R square. I will later on explain all these things when I will create a ML model. Okay, just remember this thing. When to use what metric. Now coming to classification metric. First one, accuracy, meaning percent of correct prediction. Formula, correct versus total. When to use balanced classification dataset. When dataset is balanced, same all the categories dataset are number are same. Next is precision, meaning correctness of positive prediction. Formula, true positive by true positive plus false positive. When to use? When false positive are costly. Example, spam. For spam detection, the precision is very important. Recall, detect ability. Equation, true positive by true positive plus false negative. When to use? When missing positive cases is dangerous, like cancer. So healthcare related problem we can use recall. The last one is Apple score. The balance, precision and recall. Equation, harmonic mean of precision and recall. Actually, Apple score both the precision and recall. When to use? Imbalance dataset. That means suppose in dataset two type of category. So two category dataset are number of data set per category not equal. Some is very large, some is very low. In that case, we can use A4 score. And also some advanced error metrics like clustering model. For clustering model, silhouette score. Silhouette score used for unsupervised model like K-means. It measures the quality of clustering by checking the separation distance between resulting clusters. Another is computer vision. That is IOU, intersection over union. This might be used for object detection model like CNN, convolution neural networks. It measures the overlap occurrence between the predicted bounding box and the actual object. Now NLP and LLMs, perplexity and view. These two metrics used for language models like ChatGPT. Perplexity measures uncertainty in prediction, while view compares generated text against actual text. Now, tabular format, I'm again showing the real column and which model we have to use and what metrics we should use and why. So now house price prediction. Model we should use linear regression, error matrix, RMSE. Why? Measure average price prediction error in origin rate. Spam detection, logistic regression, metric, precision. Why? False spam is highly annoying. Cancer detection, random forest, error matrix recall. Missing a real cancer case is dangerous. Fraud detection, XGBoost, use F1 score. Fraud datasets are highly imbalanced. So need balance. Okay. Now ChatGPT text generation, we should transform our model and measurement is perplexity because measures the language prediction, quality and uncertainty. Okay. So this is the table of real problem, what model have to use, what metric we should use and why. Okay. So now I'm showing you the ML training loop. Simple training loop. This is the neural network makes an initial guess based on its current data understanding. So predict, then calculate. The chosen error matrix calculates the loss or mistake mathematically. Then adjust based on the metric. We will adjust the model parameter and the model predicts again. I mean now improve and actively reducing the overall error on each process. And again we just predict and uh, repeat the same process. Okay, this is a loop. So ML philosophy is like machine learning model never becomes perfect. They simply try to minimize error. The error matrix is essentially the ultimate report card of model performance. Okay, so this is the golden rule of ML evaluation. So that's all for today. Thank you.